5 for week 5. Today we're going to be going over reviewing some equations of lines, some factoring, and solving quadratic equations. So the very first thing that we're going to look at is writing the equations of lines. In question 1, it says write the following equation in slope-intercept form with the given criteria. Well, first of all, we need to know exactly what slope-intercept form is. Slope-intercept is always going to be y equals mx plus b. So we're using the given criteria to make sure that we can have an equation that is in y equals mx plus b form. So looking at question A, it gives us a slope of 2 and a b of -7. Well, that's really nice and easy. All we have to do is put them in their correct place. We know that y equals m is going to be 2x. B is -7, so we're going to put -7. All right, B, it says we have a vertical line that passes through the point 1, -2. So to give you a nice little visual, I'm going to draw a graph. Okay. I'm going to draw a graph. So if I remember, a vertical line goes up and down. Okay, so I have my line that goes through it. And if I notice, it only goes through the x-axis. So all I care about is the x value. So I know anytime I have a vertical line, I'm going to say x equals what is going on here? So I'm going to say x equals whatever that x value is, and in this case it is 1. All right, then we're given a horizontal line that passes through the point 0, -5. Again, I'm going to give you a quick visual. We have a graph, and we have a line that goes horizontally. So it only crosses the y-axis. So again, all I care about is the y value. So I know y equals -5. All right, D, we're given a slope, and then we're given a point that it passes through. So the easiest method that I can tell you to use for problems like these is we're going to use the point slope form to solve these equations. So we have point slope. And this is actually really quite simple. We have y. Okay. We have y minus y1 is equal to m parentheses x minus our x1. Remember, the only time that we're plugging in our values are for the y1, the m, and the x1. So when we go to work this problem, we have y minus our y1 is 8, so -8 equals m. Sorry, our m is actually 1/2, so 1/2 x minus our x1, which is -4. So I'm going to plug in a -4. So I get y minus 8 is equal to, well, if I distribute that 1/2, I'm going to end up with 1/2 x. This negative becomes a positive 4, so I know I'm going to have 1/2 times 4. Well, half of 4 is a positive 2. And to finish it, to get it into y equals form, I know I'm going to add that 8 to the other side so that I end up with y equals 1/2 x. 2 plus 8 is 10. So my final equation is y equals 1/2 x plus 10. All right, for question E, again, I'm given a slope and I'm giving a point that it passes through. So I know I'm going to use point slope form. So again, I have y minus, in this case, my y1 is going to be 0. So y minus 1 is, or sorry, y minus 0 equals, my slope is -3. And then x minus, in this case, I have a -1, so I plug in that -1, making sure I use my parentheses because I know that that negative becomes a positive. And I know I'm going to distribute that -3 to both of those. So y minus 0 is just y. That becomes a -3x. And then -3 times a +1 is going to be a -3. So my final equation is y equals negative 3x minus 3. All right, F. I'm given 2 points, and I know that it passes through. So I'm going to have to first find the slope. So I need to know my slope. We know that m is equal to y2 minus y1 over x2 minus x1. So I'm going to start with negative 4 minus 0 over negative 3 minus 0. I should get negative 4 over a negative 3. Negative negative obviously becomes a positive, so that's just a slope of 4/3. Now again, I'm going to choose one of those points to use. It doesn't matter which one I choose. I'm going to choose the easiest one, which is going to be that 0, 0. So again, I have y minus 0 equals 4/3 times x minus, again, 0. So whenever I do my math, I get y equals 4/3 gets distributed, so that I just get 4/3 x. So my answer is just y equals 4/3 x. For G, again, I'm doing the same exact thing. I'm given 2 points, so I know I'm going to have to find the slope. So I have m is equal to negative 1 minus 7 over 6 minus my negative 2. Negative 1 minus 7 is going to be a negative 8. 6 minus a negative is going to be 6 plus 2, which is also an 8. Negative 8 divided by a positive 8 is going to be a negative 1. Now again, I'm going to choose one of those points. It doesn't matter which one. So we're going to get y minus 7. I choose the first point. My slope is negative 1 times x minus, since I use 7, I will use negative 2. All right, so I know that that negative negative becomes a positive. I get y minus 7 is equal to negative 1x. And that negative 1 times a positive 2 becomes a negative 2. To finish the problem, I need it to be in y equals, so I know I have to add 7 to both sides, so that I get an answer of y equals negative 1x. Again, that is the same as just saying negative x. Negative 2 plus 7 is going to be a positive 5. So you could write it as y equals negative 1x, that's okay, or you could write it as y equals negative x plus 5. Either one of those are just fine, and they are both technically the same answer. So now we are going to look at factoring. So the very first thing that we always look for is the greatest common factor. Okay, that is the one thing that both have in common. Okay, and he is step one anytime you are ever factoring. So this means that we're going to pull out, there is no format, we just pull out the greatest common factor of each of them. Okay, so we're going to take a look at our very first one. We have 3y squared minus 15y. I need to know what those two things have in common. Well, 3 and 15 both have 3 in common. Y squared and y, I can only take one y maximum out of both of them. So I'm going to divide by 3y for both of them. And that 3y now comes to the front. And now I'm actually going to do my division. 3 divided by 3 is just 1. Y squared divided by a y is just y. Negative 15y divided by a 3y is going to give me a minus 5. So my final answer for factoring is 3y times y minus 5. All right, again, I'm looking for the max number and the max variable that I can take out of all of my expressions. So looking at 6, 24, and 12, I know that they all have a 6 in common. So I can pull a 6 out of all of them. Out of x5, x squared, and x, well, x is the smallest, so he is the only one that can be taken out. So that 6 that I pull out goes out in front. And now I'm going to divide. 6 divided by 6 is 1. X to the 5th divided by x, well, he just goes down 1. So that becomes x to the power of 4. Negative 24x squared divided by 6x, that becomes a negative 4x. 12x divided by 6x is just a 2. And that is my final factored answer. For C, again, I'm looking at my numbers first. I'm going to go 7, 49, and 14. Well, they all have a 7 in common. So I know I'm going to divide them all by 7. Now again, I look at my a's. I have a squared, a cubed. I can only take out the smallest that they all have in common. So that's just going to be 1a. B squared, b cubed, b. Again, the smallest that I can take out is a b. And then I'm going to take that, what I pull out, and move it to the front. And now I'm going to do my division. So a squared, b squared divided by ab is just going to be ab left over. Negative 49 divided by 7 is minus 7. A divided by a, well, that's just 1, and I don't care about a 1. B cubed divided by a b becomes a b squared. 14 divided by 7 is a 2. A cubed divided by a just becomes an a squared. B divided by b is just a 1, and I don't really care about keeping a 1 in my number. So my final answer is 7ab times ab minus 7b squared plus 2a squared. Now, looking at D. This one is actually already broken down, and now I'm looking for what do these two expressions, again, this is an expression, this is an expression. I'm looking for what do they have in common. I notice that they both are being multiplied by x minus 3. So I know I'm going to pull out the x minus 3 that they both have in common and move him to the front. That 5x and 3 that are left over, well, they just also join their own parentheses so that you get 5x plus 3, and that is your final factor. So now we're going to look at a trinomial without a lead coefficient, meaning the lead number is a 1. So the format, we usually see this as ax squared plus bx plus c. And the method that I tend to use is kind of a visual one. If you don't like to do this method, that's okay. But for visual purposes, I know that I'm looking for what times what multiplies to give me that c at the end. And also, the same numbers must add to give me that b in the middle. So when I'm working my problems, I'm going, okay, what times what gives me that 6, but adds to also give me that 7. This is where knowing my factors and knowing how to add and subtract positive and negative numbers comes in handy. So looking at my first one, what times what gives me 6 and adds to give me 7. Well, my factors of 6 are 2 and 3. 2 and 3 do not add to be 7, so it must be 6 and 1. Oops, too thick. So 6 times 6 gives me 6 and adds to give me 7. So I know that those are going to be my factors. So I get x plus 6 and x plus 1. Again, it does not matter what order these are put in because when you multiply them out, they are going to be exactly the same. So it could be x plus 6 first or x plus 1 first. Doesn't matter. But that is my final factored answer. Now again, I'm looking and I'm going, okay, what times what adds to give me that -3 at the end? And what plus what adds to give me that -2? I think I said that wrong. What times what gives me -3 and adds to be a -2? Well, the only thing that gives me a 3 is 1 and 3. How do I add them in a way to get a -2? Well, the largest number must be negative, and the smaller number must be positive. So when I plug them in, I make sure I keep their signs with them. So I get x minus 3 and x plus 1. All right, again, looking at C, I want to know what times what gives me the 8 at the end, but adds to give me a 6. Well, my factors that give me 8 are just 2 and 4. 2 and 4 just so happen to also add up to be 6. So I take those two numbers I got and I put them inside their factors. So I get x plus 2 and an x plus 4. D. Well, first thing I notice is D doesn't quite look right. So I actually need to rearrange him so that he is in descending order, making sure that the sign that is to the left stays with him. So I get negative x squared minus x, and that's a positive 20 at the beginning. Now, I need it to be a positive 1 in the beginning of my expression, so I cannot have a negative number to start. So I know I'm going to also have to pull out the negative. Well, if visually looking at this, that means I'm dividing everything by a -1, and that negative is going to go out front, and everything is now positive. So that's x squared plus x, and that becomes actually a -20. Now all I'm dealing with is what's inside of my parentheses once I've pulled out the negative. So again, I'm looking and I'm going, well, what times what gives me a -20, but adds to give me a positive 1. We have to understand understood ones, okay? We know that technically that is a 1 in the front of those x's, but we don't tend to write them. If you need to write them, that's okay. You can do that. So what are my factors that give me 20? Well, 4 and 5. Well, I need them to be a -20, but a positive 1. So my factors, I have to have the larger number has to be positive. The smaller number has to be negative for it to be a positive 1. And if I multiply them out, I know that I end up getting a -20. So I make sure when I write my answer, that is a positive 5, and that is a -4. If all else fails, work this problem out and see if you get the final answer. And I also have to add, please do not forget, remember that negative that we were dealing with in the front? He always has to join your final answer. So that has to be a negative in the front with your factors. All right, so now we're going to be talking about grouping format. Well, what is grouping? We tend to use grouping when we have 4 expressions. So first thing you need to do is, well, look and see and count. How many things do I have? Well, I have 1, 2, 3, 4. So I know I'm going to use grouping. So the first thing I always do, well, the first thing I should do for everything, anytime I'm factoring, is do I have a GCF? All right, so GCF first. If I don't have a GCF and I notice I have 4 terms, well, then I'm going to take and I'm going to break them apart. So I'm going to I'm going to make sure I group my like terms together. And then I'm going to take the GCF, greatest common factor, of both. Okay, so looking at it, I go, okay, well, I'm going to take and I'm going to group the first 2 together. And then I'm going to group the second two together. Please remember that that plus sign goes with that 2x, so make sure you include him in there. This will come in handy later on. So x cubed and x squared, what do they have in common? Well, that x squared. Now that 2x and that negative 2, what do they have in common? Well, they both have a 2. So I'm going to take that x squared and that positive 2 that I pull out, and I'm going to put them in their own parentheses. Actually, no, I'm going to show you a different way. I apologize. I'm going to take them and I'm going to do my division. All right, so that x squared comes out front, and I end up with an x minus 1 remaining. I pulled out a positive 2, and I'm going to do my division so that I get an x minus 1 remaining. Once these two terms in parentheses are exactly the same, then I can take them and put them into their new grouped parentheses so that I take the first values and I get x squared plus 2 go into their own parentheses, and x minus 1 goes into his own parentheses. All right, so let's take a look at our next one. Again, I'm grouping. I'm making sure I put my first two terms together, and now I do my second two terms together. Notice that negative, I kept him into that second parentheses. So I'm going to find their greatest common factor. X cubed, 5x squared have just an x squared in common. So I pull out an x squared. That negative 5x and negative 25, they both have a negative 5 in common. So I'm going to write my new factors. I get x squared. When I do my division, I'm left with an x plus 5. That negative 5 goes out in front, and I'm left with an x. Negative 25 divided by negative 5 is a positive 5. I double check to make sure that my parentheses are exactly the same, and I'm going to write my new factor. The numbers out front go into their own parentheses, and that x plus 5 goes into its own parentheses. Again, I group. I'm grouping the first two and the second two. What do they have in common? Well, in this case, we only have x's in common, and it's the smallest one, so I get x squared. My next one, well, they don't technically have anything in common, but for the sake of visuals, I know that they both have a 1 in common. So I do my division, pull out that x squared. I'm left with x minus 5. I need to remember this 1. Technically, he is there. It is a positive 1. Dividing by a 1 doesn't do anything, but it does make it x minus 5. So I know I now have matching parentheses. I'm pulling the front, x squared plus 1 out front into its parentheses. That remaining x minus 5 goes into its own parentheses. All right, last one. Factor the first two, second two. Pull out their GCF. In this case, it's the x cubed. And the second one, it's just a 3x. So now I'm left with x cubed out front. I divide and I get an x minus 1. That's a positive 3x out front. Do my division and I'm left with an x minus 1. These two numbers are the same, so I know I did it correctly. If those two numbers are not the same, then you need to go back to the beginning and you might need to rearrange your original equation, or look at maybe pulling something extra out. So I write my new factors as x cubed plus 3x. And then that x minus 1 again goes into its own factor. Now, I'm going to talk about trinomials with a lead coefficient, okay? So that means that there is a number out front and it is greater than 1. Okay, so that's our 4, 2, 3, negative 2. So what do? Well, number one, first and foremost, we always look for GCF. Can I pull anything out before I start doing anything else? Number two, okay, if I'm unable to pull anything out, I know that I'm going to end up doing a method that I love to use. I multiply the first number times the last. Then I do my what times what gives me C and adds to give me B. And then last and foremost, or last, I must go back and divide by my A. Okay, so this is going to make sense as we go, but it is probably the easiest method that I have been able to come up with to solve these types of problems. So, A. I look at my expressions. I have 4, 28, and 24. What do they have in common? In this case, they all happen to have a 4. So I'm going to pull out the GCF first. So I'm pulling out a 4. That 4 goes out in front, and I'm left with x squared plus 7x plus 6. All right, so now I'm looking at just what's inside. And I go, okay. Now I'm looking at it. Do I have a number in the front anymore? No, I don't. So I don't have to do the multiply the first times the last because I now get to treat it like a trinomial that starts with 1. So all I'm going to do is skip to the what times what gives me 6 and adds to give me 7. Well, we already did that. We know that it's 6 and 1. So I get to go, make sure you that number that was in the front, you're going to reuse him, bring him down. And you can use that 6 and 1 so that you get x plus 6 in one factor and x plus 1 in the other factor. And this is now your final answer. Now, looking at B. 2, 1x, negative 1, do they have a GCF? No, they don't. So now I know I'm going to use this method of multiplying the first times the last, finding my values, and then dividing again. So first times last. First times last. So that I move him to the end, I get x squared plus x. 2 times a negative 1 is going to be a minus 2. So that was my first step. Now I'm going to go and do what times what. So I know, well, in this case, what times what gives me a negative 2, but adds to give me that 1x. Well, the only thing that can give me those values is a positive 2. Positive 2, negative 1. So I'm going to write my factors. I have an x plus 2 and an x minus 1. So I did step 1, step 2. Now this is where I'm going to do step 3. Remember that variable that I multiplied to the back, that 2? Well, I'm going to take him and I'm going to divide him only to my constant, the number in my parentheses. So I look at it and I go, okay, x plus 2 divided by 2. Can it divide? Yes. Well, I'm going to divide so that I get an x plus 1. That second one, Is -1, can it be divided by 2? No, it can't. Well, then I have to take it and bring it to the front so that I end up with a 2x minus 1. This is my final factor. So if it can divide, I divide. If it cannot divide, well, I just move it to the front and that's okay. And I'm done. So we're going to do this again. This method takes practice, but it is probably the quickest method that I can teach you. All right, looking at C. 3, 11, and 10, do they have a GCF? No, they don't. So I'm going to use my method. I'm going to multiply the first times the last so that I end up with x squared plus 11x. That 10 times 3 is going to be a 30. So method 1 is done. Now I'm going to do what times what gives me a positive 30 and adds to give me 11. Well, if I know my factors that give me 30, it can't be 10, or sorry, it cannot be 10 and 3, because when I add them up, I get 13, and when I subtract them, I get 7. So it has to be 5 and 6. 5 and 6 add to be 11. So I know I'm going to now rewrite my factors so that I get x plus 5 and x plus 6. Now my third step, I'm going to divide. Remember that 3? I bring it back and I divide. Can I divide 5 and 3? No. So bring him to the front so that I get 3x plus 5. Can I divide 6 and 3? Well, yeah, 6 divided by 3 is 2. Well, that becomes x plus 2. That's my final factor. I'm done. Okay, D. One more practice round doing it. -2, 7, and 15. Do they have anything in common? No. But I should pay attention. It had a negative. I don't want a negative in the front. So no matter what, I'm going to go ahead and pull that negative out to the front so that I end up with a positive 2x squared, a negative 7x, and a negative 15. But I have to remember him. He always has to come back and join and be in my final answer. So now that I pulled out that negative, I'm going to do the first times the last. And I'm going to rewrite my answer. So I get a negative x squared minus 7x. 2 times a negative 15 becomes a negative 30. Okay, so now again, I have to do what times what gives me negative 30, but adds to give me a negative 7. Well, if I know my factors of 30, I know that I either have to look at 5 and 6, or I have to look at 10 and 3. I need a negative 7, so I'm going to focus. Can I add 5 and 6 in a way to give me a negative 7? No. Can I add 10 and 3 in some way to give me a negative 7? Well, yes, I can. It has to be a negative 10 in the front and a positive 3. So negative 10, positive 3. So I'm going to use those for my factors. Remember, don't forget that negative in the front. And then you get your x minus 10 and your x plus 3. So I did step 1, step 2, step 3, I need to bring it back and divide. Well, remember that positive 2 that I just did my multiply first times last with? Well, he comes back. And I'm going to divide by 2. So I get a negative. Can I divide 10 and 2? Yes, it's x minus 5. Can I divide 2 and 3 or 3 and 2? Absolutely not. So I know I'm going to bring him to the front so that I get 2x plus 3. This is my final factor. So remember, we never want to work with a negative in the front, no matter what. And we have to make sure that that negative that we pull out always comes back to our final answer.